A used car dealer wants to predict the selling price of a Camaro brand. 31 data were collected on the sales price of the cars, taking into account variables such as age, millions, condition, and if the car have only one owner. Here we have our table with the data. In order to estimate what the price would be, first we made two graphs, one with age versus price, and the other one with mileage versus price. And in here, we observe which type of model best represented this data. So we conclude that the multivariable one was the one that best fitted. In order to make sure if this was correct, we analyzed the data and we saw that both the years and the miles passed the p-value. Because the p-value was less than 0.05 and the r-squared was high, showing a value of 0.8. However, we were not sure if that was the best model, so we performed several tests. First, we did the one with all the variables that we have, and we saw that 3 of all the variables didn't pass the test, so we eliminated them one by one to see which model fitted first. The first one that we did was the one with no interception to see if that was okay, but the p-values were not okay. It was even worse, so we didn't use that one, and we proceeded to do the other. And we found that when we got rid of the miles, we have other two that were not into the limits. That was the one owner and the average. So we eliminated the average, and that's when the model passed all the tests, because all the p-value were under 0.05, and that's because we were searching for the 95% reliability, and we saw the r-squared that equals 0.88, which is really high, even higher than in the previous model, in the first one proposed, because the other was 0.81. So this is the model that best fits our case. That's why we proposed an equation that we are giving the coefficients in the slide with the analyzed data. So is y equals negative 2851.6.613 x1 plus 6434.931 x2 minus 33263.199 x3 plus 306094.192, having x1 as h, x2 as a condition, and x3 as if it has one owner.